This is the mini lesson for 4.4. So now we're going to work with subtracting integers. So these models get a little more confusing, so try to pay close attention to this lesson. Subtraction can mean to take away objects from a set. Subtraction can also mean a comparison of two numbers or the difference between them. The number line model and two-color counter model used in the addition of integers can also be used for subtraction. Okay, using just positive or just negative counters, we can show subtraction using the takeaway model. So for example, they're showing us 7 positives sitting on my plate, and now we're going to take off 5 of the positives. So they're showing us that 5 are coming off the plate, which means 2 positives remain. So my answer is positive 2. Okay, same thing here with the negatives. If I have 7 negatives on the plate, all 7 are there. If I am taking away 5 of the negatives, 1, 2, 3, 4, 5 come off, I'm left with 2 negatives, so that would be my solution. Those are easier. It's a little harder when we have sum of both. So I'm going to look at this example here. So first of all, recall that the value of 1 negative and 1 positive is called a zero pair, or a pair of zeros. Together they form that zero pair that I just mentioned. You can add as many zero pairs as you need, and it never changes the value. So here's another example. We start with 7 positives. So all of them are on the plate. I need to take off 5 negatives. But there aren't any negatives on this plate, so how can I take 5 of them off? So what I can do is I can add 5 negatives to my plate. But if I add 5 negatives, I've changed the value. But if I add 5 zero pairs, I don't change the value. So if I add 5 negatives, if I add 5 positives, these are all zeros. So the whole value here has not changed at all. But now I'm able to take off those 5 negatives, and what I'm left with on the plate is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm left with 12 positives. So the answer to 7 minus negative 5 is actually positive 12. So we'll do this a few times. Here's my next example. I'm starting with 7 negatives. I want to take off 5 positives. I can't. I don't see 5 positives here. So I can add 0 pairs without changing the value. So if I add 5 positives, it means I need to add 5 negatives so that I don't change the value of what is on my plate. Now that I've done that, now I can subtract or take away the 5 positives. So I'm going to take these and I'm going to slide these all off the plate. So what's still on my plate? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 negatives are still on my plate. So they're telling me here this is a little bit like regrouping in subtraction. So now let's try a few of them together. So I am starting with 4 positives. And I'm not going to keep circling them, so I'm just going to do this. I need to take away 5 negatives. There aren't any there. So I'm going to put 5 on there, but I have to add them as 0 pairs. Otherwise, I've changed the value on the plate. So the value of this still is 4 positives, but now I can take off 5 negatives. I can now grab these, pull them off the plate. What's left on my plate? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 positives would be the solution. Let's try another one. I'm starting with 4 negatives. I need to take off 5 negatives. Well, there are 4 of them here. So I need to put one more negative on my plate to be able to take off 5 of them. But if I'm going to put one on, I have to put it on as a 0 pair. Otherwise, I change the value of the plate. But now I can see I can take off 5 negatives. And what am I left with? 1 positive. So my answer to -4 minus -5 is actually +1. Let's try another. I'm starting with 4 negatives. I need to take away 5 positives. I don't have any positives here. So I have to put 5 positives on the plate, but then I have to put them on as 0 pairs, otherwise I change the value. Now I can take away 5 positives, and I'm left with 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm left with 9 negatives. That's my solution. Okay, we'll do one more together. If I start with 4 positives, if I want to take away 5 positives, I don't have 5 of them here. So to have 5, I need to add 1, but I better add it as a 0 pair. Now I can take 5 positives off, and I'm left with 1 negative. Okay, we're going to switch over to the number line model. So I'm going up to problem 3, and we're going to take a look at what this looks like on a number line. When I see these using a number line, what I'm thinking is I'm starting at -6, and this is telling me I'm moving the opposite of 2 positives. So on a number line, I start at 0, we move to -6. From -6, I'm moving the opposite of 2 positives. 2 positives normally is to the right. I'm moving 2 to the left, and I end up with -8 being my solution. Let's look at a couple more. Here, I'm starting at -6, so I start at 0, we go to -6. So now from here, I'm moving the opposite direction of 2 negatives. Normally when I'm adding 2 negatives, I'd move this way. I go the opposite, and I end at -4. Let's look at another one. I'm starting at 6, so I go from 0 over to +6. I'm starting here. I'm moving the opposite of 2 negatives. Normally I'd move left for negatives. I'm going the opposite. I go 2 over, and I end up at +8. Another one. Starting at +6, I'm moving the opposite of 2 positives. 2 positives normally would tell me moving right 2 places. I go the opposite, and I end at +4. Okay, let's try just 2 of these together then. So here I'm starting at -4. So I go 0, I go to -4. From here, I'm moving the opposite of 3 negatives. Negatives, I'd normally move this way. I'm going the opposite, 1, 2, 3, and I ended at -1. Okay, let's look at B. I'm starting at -4. I'm moving the opposite of 4 negatives. Instead of going negative, I'm going positive, 1, 2, 3, 4, and I end at 0. This is the end of the mini lesson using both number line and colored counters to solve subtraction.